Hi everyone, Mr. Rowe here. This is my second video lesson that I'm bringing to you. I'm not going to do video lessons for all of the lessons just because some of them don't really need it. If you notice the first couple lessons in this new unit, there wasn't really much math to do. It was a lot of just like terms and definitions, so I'm sure most of you could figure that out by itself. But with my experience, I know the lessons that kind of give people the hardest time, so those are the lessons I'll do video lessons in, and if I do a video lesson on a completed note, I'll have a little notation there to go view it on the YouTube channel, which will be linked in the LMS. So I hope everybody's doing really well, and we have 2 assignments in, so what we'll be doing is, every week 2 to 3 lessons, your 3 hours, and then at the end there will be an assignment, and I feel like so far that process has been working quite well. Alright, so for this lesson I did things a little differently just to try to keep things a little shorter. I already have the note completely filled out, so I'm just going to go through it and talk through it because I filled out this note and it took well over an hour, so I'm sure you don't want to sit here and watch me fill out a note for an hour as I talk through it. So this should go by a lot quicker, and I can go at this pace and not feel bad because you could just pause me at any time, go back, rewatch. You can stretch it out as long as you want, watch it multiple times, so the pace is going to be rather quick. But of course, if there's any questions, you could always message me and I'll do my best to answer any of your questions. So I might mess this up a bit. This is the completed note that is uploaded already. I'm going to probably add a bunch of stuff, just random arrows and such that won't be there on the LMS version. So anyway, this is 2.5 measures of central tendency. So as the name suggests, we want measurements that focus on the center of the data. So there's 3 of them we're going to look at: mean, median, and mode. You're probably already familiar with one or more of these, but we'll just recap these quickly. These are just the definitions, and what I've done is I've circled here the main point. This explains how to calculate a mean. You add up all the values and divide by the number of values. The mean is known as your average. So just for notation purposes, if you are taking the mean of an entire population, you're going to use the Greek letter lowercase mu. Okay, and when you divide by the number of values in the population, it's a capital N, as opposed to if you're taking a sample mean, a mean from a sample, use this little notation. It's x with a bar on top, either called x bar or x hat, and the number of values is notated with a little n. So they're the exact same formula, just different notations. The median is the middle value of the data. So you see that one on your report card, and what that means is if our class has a median of 75, that means half the students have marks above 75 and half the students have mark below 75. So knowing that value, you will know if a certain data point is in the upper half of the data or the lower half. And the mode, which is the least frequently used, is the data point that shows up the most in the data. Outliers, just as a reminder from grade 9, are values that are kind of distant from the majority of the data. And as we're going to see, they have a great effect on a mean, but not necessarily a median, and we'll talk through that in our example. So I've already taken the liberty of calculating all these for you. So if we're looking at class A right here, and I want to calculate the average, these are all the students' test scores in this hypothetical calculus class. I'm just going to add them all up, and I counted there were 17, so I add them all up and divide it by 17. I got an average of 71.5. If I want the median, I need to put them in order from lowest to highest. So what I've done is I've rewritten all of these down here, starting with the lowest all the way up to the highest. Now, a little trick to find the middle value that I use and I find useful is, how do you know like it's going to be the 9th value? How do you know this is the middle one? It might be easy and trivial with a small data set, but what if you had like 1,252 terms? How would you know where the middle is? Well, what I do is I take the number of terms, which in this case is 17. I just do a plus 1 and divide by 2. So 17 plus 1 is 18 divided by 2. That gives me 9. So that way I know that the 9th value, which is this one right here, is going to be the mean, the average. And for the mode, I'm just going to look up for the one that shows up the most. In this case, it is 71. As you can see, it shows up 3 times. You can have multiple modes, as you're going to see in Class B, or if these are all unique values, you would just say there is no mode. So Class B, pretty much the exact same calculations. The only difference is there's one extra student in this class, which means there's 18. So the mean is calculated the exact same way, so I won't go over that again. Add them up and divide by 18. But for the median, because there's an even amount of values, you can't find a unique middle value. Up here, with the 17 values, there's 8 in the top half, 8 in the bottom half, and 71's right in the middle. You can't do that here because there's 18. So using that little trick, that'll help us determine how to do this. So if I go 18 plus 1 divided by 2, I get 9.5. So what that's going to tell me to do is to take an average of the 9th and the 10th value. So I'm finding the average of these two values, and that'll give me a mark as seen in the calculation of 71. So 9 of these values are above 71, and 9 of these values are below 71. The next questions just ask you to compare the results. So if you notice, the medians were the same. They were both 71. So would you say the performance in these classes were equal or not equal? Well, if you look at the mean, you'll see that the mean for Class A is pretty significantly higher than the mean for Class B. So if you were just looking at this, would it be fair to say, well, Class A is way better than Class B? Well, not necessarily, because again, if you look at the medians are the same. Half the class has above 71, and half the class has below 71. So what's going on here? And the reason we see this big discrepancy with the mean is because we have a couple of outliers here. We have 2 students that had marks of 12 and 15. Those are going to drastically bring down the average because they get counted at that value, but not really have any impact on the median, because these marks would count just as much as any mark lower than 71. This could have been 65, 65, and it would not have impacted the median because it would have still been on the lower half of the data. So the summary is that outliers can have a big impact on the mean, but not as much necessarily on the median. So that's probably why you see a median mark show up on your report card. Because maybe I have a couple students who've never showed up, they're still on the register, and they have zeros in my class. Well, would it be fair to count those zeros to show the performance of my class? No, because those zeros would significantly bring down my average. So moving on, we're going to calculate something that's called a weighted mean. So you kind of experience this all the time. Anytime you get back a test, I see a lot of you just add up your total marks that you got in the 4 categories and divide by the sum of the categories. Now, that's not horrible because the higher weighted categories happen to be worth more marks. So there is kind of a built-in weighting system, but it's not going to give you 100% an accurate mark. And there is some potential, depending on how you do in certain categories, to have a mark that's not going to be reflective of a true weighted mean. So what I mean by a weighted mean is, for you guys, anytime you have a test, your knowledge marks are worth 25, your application marks have a weight of 25, your thinking marks have a weight of 10, and your communication marks have a weight of 10. So marks that you get in knowledge and application are worth more than marks you get in thinking and communication. So after I show you this, you should be able to calculate your true mark on any one of your tests going forward or assignments. So these formulas look scary. So this is part of the reason why I wanted to do a video lesson. I don't want you to look at this and be like, oh my goodness, this is crazy. What is all this? This Greek letter here looks intimidating, but it's really not. Anytime you ever see that symbol in mathematics, it just means the sum of. Sum of whatever. So it's whatever comes after that is what it wants you to add up. So in this case, it's telling me to take all the weights, take all the values at that weight, and add them all up. And then you're going to divide by the sum of all the weights. And you know what, if you don't even want to, you don't have to memorize this formula or anything, you just have to understand that you just take your mark, multiply the weight, do that for each mark, add it up, divide by the sum of the weights. So we'll see an example down here. So here's a scenario where someone's applying for Microsoft and they're being assessed on these certain score or these criteria: education, job experience, interpersonal skills, communication skills, and references, and they're not all worth the same. If you notice, there's a weight factor. So, as outlined down here, you'll see that they're putting an emphasis on your communication and interpersonal skills. So doing better in those categories, will help your mark. Whereas references is worth the least. So even if you do really well on that, if you don't do well in these other categories, your mark may not be as high as you think. So all this formula is telling me to do is take each mark and multiply it by its weight. So this guy got a 4 for education, and that weight factor is a 2. So I'm going to go 4 times 2. So what I'm going to do is do that for all of the scores and all of the weights. So you see I've already done that here. So this part here, this sum of all the scores times the weights, that value is here. This is me doing a sum of all the scores times the weights. So when that's all said and done, it just equals 46. So if you're doing an assessment for me, you don't even need to show me this big formula. If you know what you're doing, you can just calculate this, get the total, put it here. And then what are you dividing by? You're going to divide by the sum of the weights. So here's all the different weights. The sum is 11, that goes into the denominator. So his weighted mean is about 4.2. So how does this compare to if they just calculated his mean without the weights? So in this case, you'd calculate mean just like we did before. You're going to take all the scores, add those up, they equal 20, and there's 5 criteria or 5 scores, so you go 20 divided by 5. So you see that his score, his non-weighted mean is 4, so it's actually a little lower. So the next part of this question wants you to kind of account for this discrepancy. Why is the weighted mean higher than the non-weighted mean? And that's because he got maximum value of scores in the categories that were worth the most. So if you're ever writing a test and you do extremely well in knowledge and application, and maybe the communication and thinking doesn't go so well, maybe you don't have to beat yourself up too much, because as long as you're doing the best in the categories that are worth the most, then you're probably gonna end up okay. So moving on, now we're gonna do calculating the mean and median for grouped data. So what this means is I have, and again, another really intimidating looking formula, but maybe it's not so intimidating anymore now that you know what this means. So all this wants me to do is take the sum of the frequency times the midpoint divided by the sum of the frequency. And we'll kind of talk through why we're doing this as we go through it. So here's the scenario. A bunch of kids were asked how many hours a day they spend watching TV. And the results are shown below. So this is grouped data. I have an interval here. This is between 0 and 1 hours. I have one child. It's not like 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. This is an interval of possible values. That's what makes it grouped data. So as you can see, there's 4 kids between 1 and 2 hours. There's 7 kids between 2 and 3 hours, 3 kids between 3 and 4 hours, etc. So how are we going to calculate a mean from this? So the problem we have is, for example, let's take a student in this interval right here. Let's pretend this is me or one of my kids, and I fill in that, yeah, they watch between 1 and 2.
Well, what does that mean? Does that mean they watched 1? Does that mean they watched 2 hours? Does that mean they watched 1.5, 1.6 hours? There's no way to know. So the best we can do, we're not going to assume anything. So the best we can do is just kind of assume that, on average, the people who are saying this, on average, probably watch about 1.5. That's the fairest thing we can conclude. There's no way to know if it's closer to 2 or closer to 1, so we just say, okay, approximately probably 1.5. So that's why we need the midpoint. That's why the midpoint is in this formula. So the people saying in this interval, well, I don't know, is it 0 or is it 1? So we're going to say on average 0.5. Now there's one child in that interval, so it's going to be 0.5. So if I were to actually start writing out this data set, the first child would be 0.5. Between 1 and 2 hours, the average is 1.5. So there's 4 kids watching TV in this interval. So how many cumulative hours have these kids watched? How many hours have these 4 kids watched on average? Well, it's going to be 1.5 times 4 is 6. So there's going to be 4 kids watching what I can only assume is close to 1.5 hours. So that's the first 5 students. So while I'm here, maybe I'll talk about cumulative frequency table. So what this is this is a column which adds up the total so far. It's like a running total. So after this interval, I had 1 total student. After this interval, I had the student from up here plus these 4 new ones, so my running total was 5. So in this next interval, we have kids watching TV between 2 to 3 hours. So again, I don't know if that's closer to 2 or 3, so I'm going to assume that it is on average probably close to 2.5, and there are 7 of these kids. So this is me writing the full data set. Now you're never going to do this. This is just me doing this for demonstration. It'll help us on one of the later questions too. 1, 2, 3, 4, 5, 6, 7. Okay, so how many hours, cumulative hours, do these 7 kids watching 2.5 hours do? Well, I would do 2.5 times 7. So that's exactly what the formula is telling me to do. Multiply the midpoints by the frequency, the number of kids. So in this interval, it's 2.5 hours for 7 kids, so those 7 kids watch 17.5 hours. And then I'm just going to continue to do that for the rest of the kids. So I'll kind of just continue to do this. So we have 3 kids at 3.5. 1, 2, 3. Then I have 2 kids at 4.5. And then 1 child at 5.5. So this is the complete data set of the 18 students. Now you could write this out and add all these up and calculate the mean, but why would you want to do that when you could do this? We've taken a big shortcut here. So these are all the cumulative hours watched by the kids in these intervals. So we would add these up. The total hours of television watched is 49. You can double check. If I add up all these, it's going to equal 49. And then there's 18 kids. The sum of the frequencies, 18. So on average, we would get 2.72 kids. Or sorry, 2.72 hours of TV watched. And again, this is not going to be an exact value. It's just an approximation. It's the best we can do considering this is grouped data and it's in intervals. So I'm going to leave this up here and it's going to help me with the median on the next question, which I think they ask for. So there are 18 values. So I need to find, as we did before when we were calculating median, we need an average of the 9th and 10th value. So this is me showing the 18 plus 1 divided by 2, 9.5. I'm going to find the 9th and the 10th. Now, how am I going to find this from an interval chart? it's not as easy. Now, if I said, hey, here's all the data, find the 9th and the 10th, well, it would be no problem. 1, 2, 3, 4, 5, 6, 7, 8. Here's the 9th. Here's the 10th. I would average those out, and you would get 2.5, which is what I have here. But how are you going to do that without writing out the list? Well, that's where the cumulative frequency comes in handy. So if you see, as you can see, I've continued to fill this out. So when I was here at 5 students so far, when I add the next interval, which contains 7 students, what's the number of students in my running total now? Well, I had 5 before. I've added another 7, so now I have 12. So what this is telling me, this number 12, what that means is that between the interval of 0 to 3, there are 12 students. Or I should use these midpoints because I'm going to relate it back to here. So that this means that the running total from 0 to 2.5 is 12 students, and that's what you see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then that's where the 2.5 students end, and then the next 3 students are going to be 3.5s. And then the next 2 students are going to be 4.5s, and then the last child is the 5.5. So if you can read this correctly, this will tell you where the values are. So I need the 9th value. Well, I know that up to 5 is in this interval. So that means that 6, 7, 8, 9, 10, 11, and 12 must be in this interval. 13, 14, 15 are in this interval. 16, 17 are here. And the 18th child is here. So if we need the 9th and the 10th, they're both going to be found in this interval. And that's what I've done over here. So I knew they were both in the 2.5 hour interval. So I did 2.5 plus 2.5 divided by 2. You get a median hours of TV watched of 2.5 hours. And when it comes to finding the mode, this is very easy with the group data because it's giving us the frequencies. So the mode, well, there's 7 students watching 2.5, so you can easily see that down here as well. That 2.5 shows up 7 times, so that's the mode. And if they want the modal interval, they just want this. And there you have it. So we did save a lot of time doing it this way. So going forward, it does take a while to fill out these notes. I feel like the shorter videos probably better. Maybe you could let me know, or maybe I'll send out a little survey to see which you prefer. If you prefer to see the notes being filled out as I work through the question and the video is going to be a little longer, I don't mind doing that. Or if you like the filled out notes version where I just kind of talk through it rather quickly, so it's hopefully a 20-minute video or so, I can do that as well. So I'll try to maybe get your feedback on that and go from there. So here's the suggested homework. Again, I'll probably post another lesson or two. Again, we're aiming for 2 to 3 lessons per week, and then when we get to the end, we'll have our next assignment. So check the LMS every day, and good luck. Thanks.